Hi everybody, my name is John Broom and I'm the co-founder of IQ Motion Control, and we're here to introduce the next generation of electric motors. Over the past 60 years, there have been some incredible advancements in technology. Old technology like cars, industrial machinery, and medical devices have improved significantly, and new technology like drones and 3D printers have emerged. Despite these advancements, the motors that actually make these machines move haven't changed since the 1960s. They've become the norm, but if you actually measure their performance, they're noisy, inefficient, difficult to control, and we've reached a point where they're holding industries back. That's why we created the IQ motor module, which is an integrated motor and controller with an embedded position sensor. With position sensing and our advanced calibration and control algorithms, we're able to optimize motor performance. Due to slight errors in the manufacturing process, motors experience resistances as they spin at each angular position, and these resistances cause the motors to underperform. But because we have a position sensor, we're able to map those resistances and quantify their values and essentially cancel them out electrically. And the result, we make a $15 motor perform as well as a $130 motor. There are many advantages to sensor motor technology. Our motors are 20% more efficient compared to standard brushless DC motors, and we're 10 times more efficient compared to stepper motors. So to put this into context, if a moderately sized factory switched from stepper motors to our motors, they could save approximately $100,000 per year in electricity. Our motor calibration algorithms make motors significantly smoother and quieter. They reduce motor vibration by up to 88%. And perhaps our biggest advantage is our enhanced motor control. In position applications, our motors are smoother and more precise, and they'll never get lost. So this is a video of a robotic arm spelling out the word ModLab with a very inexpensive motor. The green line is driven by a standard controller, and the blue line was driven by our controller. And as you can see, the blue line maps much closer to the command. In high-speed applications, our motors are much more responsive, can reverse without delay, and offer precise RPM feedback. We've actually gotten a lot of interest from drone companies in the reversibility aspect of this technology because they make the vehicles much more maneuverable and reliable. Using this core technology, we're able to tailor solutions to a wide range of industries, including high-speed applications like drones and personal mobility devices, and position applications like industrial machinery and medical devices. We've actually worked with companies within each of these industries, and while they all have different products, they have one thing in common. Current motor technology just doesn't cut it for them anymore, so they switched to IQ to provide a complete motor control solution. Before now, these companies were forced to either sacrifice performance by buying inexpensive motors or spend a lot on high-end motors and motion control systems. We fill this gap in the market nicely because we offer the efficiency and smoothness of the high-end motors, the controllability of the industrial servo motors, at the price of the inexpensive motors. And since we've already written the software to drive these motors, the only additional cost is a $2 position sensor. We plan to take on the entire brushless DC motor and stepper motor market, which is estimated to be around $20 billion per year. Our initial target market is the drone industry, but we plan to quickly expand into making motors for industrial machinery, medical devices, and personal mobility devices. We've been working with Chinese manufacturers, and we plan to hit the mass market in early 2018. We plan to sell our motors to small companies and individuals, and large companies, but we ultimately plan to license our technology to these large companies, which will be specifically high-end OEM manufacturers. For these licensing deals, we'll have a flexible pricing model dependent on volume and feature set. Our team consists of myself and Matt Piccoli. Matt recently received his PhD from UPenn and is the brains behind our sensor motor technology. To conclude, I just have one question. If everything's shifting to electric, why wouldn't you want the best electric motors and most advanced motion control systems? Thank you.